Welcome to Talk Universe. I'm Charles Schultz, and we're going to be talking all about, imagine that, Mars. In particular, today's show is all about finding water on Mars. Now, I've been a long time proponent of the idea that there are active geysers in a water table. We're going to look into that in great detail, and I think you're going to be pretty surprised by some of the things you see. So, for today, I am broadcasting from inside my Mars gallery in the Virtual Science Center, and you can kind of see what the facility looks like here. We have halls of Mars images, data, research results, fossils, so on. And if you go online, you can visit the gallery directly. Go to the Schultz Laboratories website, walk over to the teleporter that says Mars Gallery, and step on it. And it will take you to the Mars Gallery, which is directly behind me. You can walk around and it's just like a real museum and see all the exhibits. And please do that. I think you'll enjoy it. If you have an Oculus or a Vive headset, that might enhance the experience for you somewhat. So anyway, today's show is all about water on Mars. So let's talk about that. Now, I did a lot of research starting back in 2004, and even before I'd written articles and published them about the planet. But in this particular show, I'm going to propose a very simple thing. Suppose you're stuck on Mars and you need to find water. What do you know about where it would be located or what it would look like? What are the signs? So that's what this is all about. This is all about water on Mars, and I think you're going to really enjoy this episode. So let's get started. So let's start right away with some images and the basic premise. So suppose you're on Mars and you're looking for water. You know that there are geysers present, but what are the signs that you would look for so that you could recognize them? Now, it turns out that's not really that difficult. There are some simple things you can spot, and I'm going to show you a few images here so that you will be able to know exactly when you're looking at a geyser. Let's start out with something pretty simple. Suppose you're looking at the ground and you see nothing but sand. There's not a lot of clue to work with in those circumstances. On the other hand, if you notice that there are slabs of stone like the broken polygons that seem to line the floor of Meridiani Planum, then you have your first real key to finding what you need. To understand why, we need to ask a simple question. What is a geyser? How does it form? How does it operate? These are things that a lot of people have never really considered. The fact of the matter is, terrestrial planets such as the Earth should have water tables. Now, what is a water table? It's an area under the ground where there is a natural flow of water similar to a river that moves through the substrate. Sometimes it literally is a tunnel with water moving through it. This is how you drill a well and reach a layer of water that you can pump out in many cases. Well, this does exist on Mars, but how do you know it when you see it? Some geysers we often think of as being like Old Faithful erupting into a huge plume of spray. But in many cases, it's as simple as a sand boil, an area where the sand seems to be flowing with a small amount of water rising from below the ground. This is often known as an artesian source or an artesian well, simply meaning that its natural pressure is great enough to force it to the surface. So here's the thing. When I'm referring to geysers, what I'm really referring to is water that exits underground and appears on the surface. It may spray with great force. It may simply dribble out. It may sometimes leak like something related to a weep zone, an area where moisture simply slowly appears at the surface without spraying or announcing its presence other than a damp spot on the soil. This can all be different at different times of the year or season, or based on the different conditions existing underground that we can't directly see. All of these sorts of things exist on the Earth, and by extension we should expect that they also exist on Mars, and in fact they do. But don't expect to find a river or stream, because you see the sand, the soil on Mars, has little or no organic matter present to slow the drainage. So imagine pouring water into a sandbox and think about where that water ends up. It moves very easily through the sand and vanishes. So to see this water, you're going to have to be there when it happens and watch carefully. It isn't going to last very long under most circumstances. Sometimes there will be an area like a weep zone. Water will ooze up in this area and leave a dark stain on the surface of the soil. These will be apparent for a while, But when they dry, they will vanish and sometimes leave behind a crust of white material, which is very likely salts that have been dissolved and then left behind in the soil. Some eruptions are rather gentle, just a flow of water coming out of a stream that eventually tapers off and leaves maybe a mark on the soil. Some eruptions are actually quite explosive. In these cases, consider the sand and grit that is carried with the water and how when it's sprayed against the soft rock around the areas, it can erode troughs and channels, wear into the rock, and actually release spherules that are trapped inside the sediments to start with. In these cases, we should look for troughs or channels that are cut in the soft bedrock. We should look for features that look as if they have been eroded in unusual manners. Smooth rocks, rocks with layers and laminations that are actually quite accented. These are all signs of abrasion, and water spraying out of a geyser can carry the sand and grit and act as a force of abrasion. So let's start by examining some features such as weep zones. We're going to go to Opportunity Sol 37, and you'll see a little water has flowed out here, and I'm going to highlight that so it's a little more clear. This is pretty obvious. Now, if we go to, let's go to Curiosity Sol 587 here, and there are 3 small areas of weep out of about 8 in this linear feature. And they change daily, so we have to continually watch them. On Sol 712, also Curiosity, a very clear feature here showing a dark flow line. But realize that even on Mars, if you were to go a half meter underground, even on a sunny day like this, it stays at a constant temperature. So you really have nothing to worry about as far as liquid water. At Sol 1429, Curiosity shows some clear flow channels, and right now it's dry. But liquid definitely flowed here recently. It didn't happen like a million years ago. If we look at Sol 1432 Opportunity, we have a definite weep zone here. And there's really no question that we're seeing the actions of liquid water. So let's talk about ejecta zones, where materials are blown out of some area under pressure. This is Opportunity Sol 122, and you can see the muddy rover tracks at the top, which implies muddy soil, wet soil. Also, there's an ejecta cone above the geyser, and it looks very much like somebody broke a water pipe, but it takes force to pile up the soil in a mound. Now, NASA referred to this as being soil subsidence, which means flowing downhill into a hole or something. And I don't see how soil can pile up as a result of subsidence. On Opportunity Sol 123, we can clearly see an ejecta cone here in the same geyser as on Sol 115. And if we pulled back a little in the view, you can also see a drainage area, which is the small hole to the left under that rock slab. Opportunity Sol 97. This geyser sprays up and out of the crater, and it basically looks just like a hole in the ground, but the spray lands here at the top and then flows down to wash the spherules down into that pile. Wind cannot do that. Sol 1426, water from under the top slab literally washed out and left that mud line. Just a meter away, this area of mud was wet on 1428. Then the next morning was cold on 429, and it's covered in frost. On Sol 2482, this flat stone has a sand wash to the left and literally mud at the top. Very obvious. If you've ever hosed off a sidewalk or a driveway, you know that a flow of liquid over a flat surface can create debris lines. I'm going to call the spherules in rows from this process bead lines. So let's talk about bead lines and how many examples we have here. Sol 121, this looks like a tide pool. Water drainage has formed these bead lines as the level slowly dropped. We also see some salt crust. There's an arc-like line of spherules above the tide pool that has lighter material on it. That's probably salt. Opportunity Sol 1029. Flow left the spherules in the low spots, as you can see. They've all filled the low areas, but the smooth slabs have obvious bead lines. Sol 1037, an absolutely clean slab with a slot where the water emerges. This is a very interesting one. You see bead lines below in the path, and directly in front, the flow rolled the spherules into a pile behind that rock. It apparently blocked the flow of liquid. Here's a small one, Sol 2512. At the lower left, you've got localized bead lines on that flat slab and muddy spherules below it, very clearly an area of mud. So let's move on to drainage areas. This is where the water goes.
So we literally have areas where water will drain away from a feature and get recycled in the underground. Sol 114 is a perfect example. This is cohesive, wet soil with an obvious drain hole under the rock. You can see flow lines in the mud. In the adjacent area, also Sol 114, we see two clear slots and wash areas that have sand but no spherules. Now let's look at Sol 126, where water has flowed over the spherules, leaving trails in the sand. Unless wind bends around a corner and pokes a hole in the ground, this has to be water. Let's talk about the large geyser field above Endurance Crater. The mud and drainage zone, the adjacent drainage slots, and next to that, this wash area and flow channels are all part of it. Farther up, you see an ejecta cone to the right, and next to that, multiple wash areas and runoff channels. Then we have obvious geyser slots, and the slabs are cleaned off in that area. You see mud and channels, and the entire area is just like this. I estimate over 40 exit slots for geysers just in this area. So let's focus on one particular geyser. This geyser from Sol 117 is about 4 inches or 10 centimeters wide. The area above it has a muddy area and everything even looks wet. Next to it you will find the runoff area and the crater edge. At the bottom and directly to the right is an obvious mud flow. The close-up shows that this is without a doubt the result of liquid, not wind. Above the mud flow and to the right is the crater lip. So what evidence do we have that this is mud? When reading the iron content of the soil to the right of this area, the Mossbauer spectrometer was pressed into the mud. As seen in this image, the mud stuck to the ring. Dry sand cannot do this. In comparison, here is the mark the Mossbauer head makes in dry sand. Other evidence of briny mud is seen as light crystals show up as the warm rover wheels drive over muddy soil. Now let's examine clay and erosion channels. Remember that the stone slabs in Meridiani are dried clay. If the slabs remain wet for an extended period, say over a week, they become soft and pliable like potter's clay. When this happens, geyser spray can deform it. Now we know what produces the splattered clay structures, but there is more. Dry clay will not deform. It will erode and form channels, delamination, and spherules on stems. So geyser eruptions carrying grit can reshape and erode the dry, hard clay, while the damp, wet clay can be deformed in interesting ways. Like these channels from Sol 37, or this one from Sol 1400, the signs are clear. This channel from Sol 1626, Opportunity Rover, it's very narrow, very concentrated. Unlike the wind, this can only be done by a stream of erosive grit carried by water from a geyser.
So I think that at this point it's pretty clear that geysers and erosion are a real thing on Mars, and finding water isn't that difficult. You look for erosion channels, you look for geyser slots, you look for water weeps, and those things are very common. We're going to see a lot of those effects no matter where you look on the planet. And it's interesting to find that Spirit over in Gusev Crater found similar things. Curiosity is finding them all over the planet, and they're in a completely different location. Of course, the lower your latitude is and the lower your elevation is, the better off you're going to be. Meridiani is actually on the equator of the planet, and it has been discovered that there are immense fields of glaciers that are only about 5 to 7 million years old by their estimates. Also, there's quite a bit of water ice in Korolev Crater. Um, that's at 70.4 degrees north latitude, if I'm not mistaken, and it's got enough water ice in there to provide everybody on Earth with more than they could ever possibly use. So anyway, with that, we're going to take a break here. This is Talk Universe. Hope you've enjoyed the show up to this point. We're coming right back shortly, so don't go away.